Yeah, hi friends. I think the physio and bio are going in a safe hand, and let's have few more interaction. And majority of them will be numericals right now. I'll go ahead. So first of all, I just want to go in detail related to the blood, that is clotting factors. So factor that participates in extrinsic pathway. Okay, so the extrinsic pathway, the factors that are involved in this is 3, 4, 5, 7, and 10. So the second question is the factors that are involved in the intrinsic pathway. The answer is 4, 5, 8, 9, 10, 11, and 12. And I hope you guys are well known that extrinsic pathway is related to the prothrombin time, whereas the intrinsic pathway is related to the partial thrombin thromboplastin time. Okay, so extrinsic pathway is related to the prothrombin time, whereas an intrinsic pathway is related to the partial thromboplastin. And the next question, the factors that are common for both the extrinsic and intrinsic pathways, that is 4, 5, and 10. You can clearly appreciate them. 4, 4, 5, 5, 10, and 10. Okay, we'll go ahead. So very clear: extrinsic pathway 3, 4, 5, 7, 10. Intrinsic pathway 4, 5, 8, 9, 10, 11, 12. Common factors are 4, 5, 10. And extrinsic pathway is related to the prothrombin time, whereas an intrinsic pathway is related to the partial thromboplastin time. Hope everything is clear up to now. And the next question, the factors that are absent in stored blood. Absent in the stored blood, the answer is 5 and 8. Next question, cryoprecipitate is rich in which factor? Cryoprecipitate is rich in which factor? The answer is 8. 5 and 8 are absent in the case of stored blood. Cryoprecipitate is rich in factor 8. Next question, hemophilia A, which is also called as a classical hemophilia, is deficient due to factor 8. And the hemophilia B, that is called as a Christmas factor or the Christmas disease, that is deficient due to factor 9. Hemophilia C is deficient due to factor 11. And the question, parahemophilia is due to the deficiency of factor 5. Something called as a vascular hemophilia, which is called as a pseudo hemophilia, that is nothing but von Willebrand factor. Clear? Hemophilia A, which is called as a classical hemophilia, due to factor 8. Hemophilia B, factor 9, Christmas factor. Hemophilia C, factor 11, parahemophilia. Factor 5, vascular hemophilia or pseudo hemophilia, is due to von Willebrand factor. So the next questions are vitamin K dependent factors or factors deficient in patient under warfarin therapy. So these are the factors which are deficient, or vitamin K dependent factors, or the factors which are deficient in the patient who is taking warfarin therapy. The answer is 2, 7, 9, 10. One more question, factors that are synthesized from the liver, all K dependent, that is 2, 7, 9, 10 plus factor 1 and factor 5. I hope you are very clear until now. That is, vitamin K dependent factors are 2, 7, 9, 10. Warfarin deficient patient who is under warfarin, the deficient factors are 2, 7, 9, 10. Liver synthesis 2, 7, 9, 10 plus 1, 5. clear, right? So we are going ahead with few numericals, that is the total cholesterol levels. The answer is 150 to 200 milligrams per deciliter. Second one, HDL cholesterol. The answer is 35 to 75. LDL cholesterol. The answer is 80 to 175. Creatinine serum levels. The answer is 0.7 to 1.4 milligram per deciliter. So glucose during the fasting, 70 to 110 milligram per deciliter. So glucose 2 hours postprandial, the answer is less than 140 milligrams per deciliter. Hope you are very clear. Normal cholesterol levels, that is 150 to 200 milligrams per deciliter. Cholesterols which are high HDL, that is 35 to 75 milligrams per deciliter, and cholesterol which are LDL, that is 80 to 175 milligrams per deciliter. Creatinine levels, that is 0.7 to 1.4 milligrams per deciliter. Glucose during the fasting, that is 70 to 110 milligrams per deciliter. Glucose after 2 hours postprandial, that is less than 140 milligrams per deciliter. So going ahead, HB values in the male, that is 14 to 16 grams per deciliter. In the females, it is in and around 13 to 15 grams per deciliter. And the next most commonly asked NEET question, that is glycolylated hemoglobin, which is called as an HbA1c. The value is 3 to 6% of total HB. pH of blood, the answer is 7.35 to 7.45. pH of urine, the answer is 4.5 to 8. pH of saliva, the answer is 7.4 to 7.6. Very clear. Hemoglobin male 14 to 16 grams per deciliter. Hemoglobin female 13 to 15 grams per deciliter. Glycolylated hemoglobin percentage is 3 to 6% of total hemoglobin. pH of blood, that is 7.35 to 7.45. pH of urine, that is 4.5 to 8. And pH of saliva, that is 7.4 to 7.6. So apart from this, I just want to make few more important values. That is the serum potassium level, that is 3.5 to 5 milliequivalents per liter. Sodium values 136 to 145 milliequivalents per liter. Urea 20 to 40 milligrams per deciliter. And uric acid, that is 3.5 to 7 milligrams per deciliter. I hope it's very clear. I'm repeating again. The potassium values are 3.5 to 5 milligrams per milliequivalents per liter. Sodium, that is 136 to 145 milliequivalents per liter. Urea, that is 20 to 40 milligrams per deciliter. Uric acid, that is 3.5 to 7 milligrams per deciliter. So apart from these values, you need to make few important notes. All the things what I'm discussing right now are repeats. Okay. So the next one is calcium. Most commonly asked question. 9 to 11 milligrams per deciliter. Next, albumin 3.5 to 5 grams per deciliter. Alkaline phosphatase 40 to 125 units per liter. Bicarbonates 20 to 26 milliequivalents per liter. Bilirubin 0.2 to 1 milligrams per deciliter. Chloride 96 to 106 milliequivalents per liter. I'm repeating again. Calcium 9 to 11 milligrams per liter. Albumin 3.5 to 5 grams per deciliter. Alkaline phosphatase 40 to 125 units per liter. Bicarbonates 20 to 26 milliequivalents per liter. Bilirubin 0.2 to 1 milligram per deciliter. Chlorine, that is 96 to 106 milliequivalents per liter. I hope it is more than enough for today. Please try to recap them whenever you have time. Signing off, Shri, MDS Conquer. Thank you.